Imagine for a second that a machine just made a life-altering decision about you. Maybe it decided whether you get a mortgage, approved a critical medical treatment, or even determined if you got a job. So, how do you actually trust an algorithm with a high-stakes decision like that? Today, we're taking a journey from the concrete, quantitative math used to evaluate financial strategies all the way to the qualitative legal frameworks required to govern enterprise artificial intelligence. Welcome to this explainer. I am so incredibly excited to guide you through this material today. We're going to explore exactly how we measure, evaluate, and ultimately build real trust in automated models. We're going to unpack the numbers, the governance, and the specific documentation required to ensure these systems behave safely and predictably in the real world. Okay, here is our roadmap for today. We're going to kick things off with the black box dilemma, then move into measuring financial performance, discuss the need for transparency, decode AI explainability, and finish up with governing trust and compliance. Let's jump right in.
Starting off with Section 1, the black box dilemma.
First off, we have to acknowledge just how incredibly dangerous it is when opaque algorithms make critical choices without any human visibility whatsoever. A black box model is essentially a system where the internal decision-making logic is completely hidden. It literally resists inspection by users. And think about it. If this logic is hidden, regulators and customers have absolutely zero basis for evaluating if the outputs are accurate or safe to act on. When the cost of an unexplained error is high, relying on a black box is simply unacceptable.
Moving right along to Section 2, measuring financial performance.
So, how have we historically solved this evaluation problem? Well, long before complex neural networks came around, financial analysts tackled this through a rigorous process known as backtesting. And there's a study from the International Journal of Advanced Natural Sciences and Engineering Researches that brilliantly illustrates this. They wrote, backtesting would be an example of a situation that allows the doctor to have an idea of the diagnosis by questioning the patient's history of the disease. I absolutely love this analogy. It takes the really complex data science of backtesting and grounds it in a super relatable human process. Just as a doctor looks at your medical history to make a diagnosis, quantitative analysts look at historical market data to diagnose a trading strategy's future viability. When we look at big assets, like Apple or Google, analysts rely on some pretty standard retrospective figures. You've got the Sharpe ratio for risk-adjusted returns, the profit factor, looking at gross profit versus gross loss, the maximum dropdown, which essentially pinpoints your worst-case scenario, and the total number of trades. But here's the thing. Relying on just these criteria across wildly different data sets, it's incredibly risky. That is exactly why modern financial engineering has evolved way past basic ratios and moved towards SRBMPR, zero-cycle behavior validation. It's a bit of a mouthful, I know, but it basically ensures that the actual behavior patterns of a model, not just its historical profit margins, are structurally validated before a single dollar of capital is ever risked. Which brings us to Section 3, the need for transparency. Now, those financial metrics we just talked about are fantastic for mathematical evaluation. But as we enter the age of artificial intelligence, math alone just isn't enough to build trust anymore. Take a look at this powerful statistic from Databricks research. 65% of customer experience leaders see AI transparency as a strategic imperative for trust. It's not just a compliance checkbox for them. And honestly, there is a massive business reason for this. The data shows that 75% of businesses fear that a lack of transparency actually increases customer churn. Simply put, if your customers don't understand how your automated systems are making decisions about them, they're going to leave. So how do we actually put this into practice? Well, a truly transparent AI program requires 4 non-negotiable artifacts for every single model you put into production. We need the AI model architecture and version history, the training data and its provenance, the AI training algorithms, and finally, your explainability tooling. And actually, for institutional audits, this documentation is increasingly relying on a deterministic market structure identification language. This is a game changer because it completely removes human ambiguity, allowing an auditor to reconstruct exactly how a model was built, and crucially, how it's going to behave under pressure. Okay, on to Section 4, decoding AI explainability. Explainability absolutely must be a fundamental design requirement from day one. You can't just bolt it on later. Now, this is an area where people often get confused, so let's clearly separate these two distinct terms. Explainability answers the question, why did the model make this specific prediction? It translates the model's computations into human-readable reasoning. Interpretability, on the other hand, answers, how does the model's internal logic actually work? So explainability is about understanding an individual output, like, why was my specific loan denied? Interpretability is about directly tracing the model's inner computational workings without needing an extra post hoc explanation layer.
Building on that thought, explainability really operates on two necessary levels. You have local explanations, which satisfy individual users by explaining a single isolated prediction. But then you have global explanations, and those are designed to satisfy auditors. They describe the overall model behavior and evaluate systemic patterns across the entire dataset. You literally need both of these levels to ensure fairness, reliability, and strict regulatory compliance across a whole organization.
Finally, Section 5, Governing Trust and Compliance.
Because here's the reality. Technical transparency alone doesn't actually guarantee safe usage. You need structural governance and strict risk management to enforce these principles in the real world. And this requires a step-by-step pipeline of transparency artifacts. Step 1 is the data sheet, which documents the origin of the data and any known population limitations. Step 2 is the model card, outlining the model's intended limits and evaluation metrics. And Step 3 is the audit log, mechanically mapping out high-stakes decisions, input features, and confidence levels. This entire pipeline must be completed and automated before any high-risk model ever reaches production. No exceptions. But here is the real kicker, the vital human element in all of this. A cross-functional AI governance committee, spanning engineering, legal, security, and business, absolutely must own the approval workflow. Transparency that just lives in a static policy document sitting on a server somewhere won't survive a fast-moving release cycle. This human committee is required to review regular risk assessments, evaluate all these artifacts we've discussed, and catch model drift before it causes real-world harm.
And listen, this isn't just best practice anymore. It is becoming the law. The EU AI Act introduces some serious regulatory bite. Article 13 mandates transparency for high-risk systems, legally requiring that users receive sufficient information to interpret the outputs appropriately. And Article 50 requires clear disclosure whenever a person is interacting with an AI system rather than a human. So regulatory frameworks are now actively enforcing these exact transparency and disclosure practices.
We have covered a tremendous amount of ground in this explainer today, from the quantitative math of financial backtesting all the way up to the organizational governance of enterprise AI. So I want to leave you with this final provocative thought on accountability. If your system made a critical error today, could you retrace exactly why it happened? If the answer is no, well, it might be time to take a hard look at your documentation and transparency practices. Thank you so much for learning with me today as we continue to build trustworthy, transparent models for the future.